Let's go slightly out of order from the notes to offer up an alternative definition of eigenvalues and eigenvectors. Although, of course, it's ultimately the same definition, just phrased differently. Suppose you know that lambda is an eigenvalue of a matrix A, and you want to find the associated eigenvectors. The equation that they satisfy is AX equals lambda X, but we don't know how to solve matrix equations where the vector, the unknown vector, appears in multiple places. Inspired by, college and high school algebra, what we should probably try to do is combine these vectors. And the first step to doing that would be to get them on the same side of this equality. Now, you need to be careful here. The naive thing to do would be to see this x, and pull it out. But that would be a mistake. You see, this lambda is a real number. This A is a matrix. This subtraction isn't defined. So here's where it will be helpful to have a matrix that acts like 1, the identity matrix, multiplying a vector by the identity matrix does not change that vector. So if we want to throw in the identity matrix here, multiplied by this vector x, we're certainly allowed to do so. And now, we can pull this x out and solve this equation. From this, we get the following definition. Lambda is an eigenvalue of A if A minus lambda I times x equals 0 has non-trivial, that is to say, non-zero solutions. These solutions are called eigenvectors. So this definition is equivalent to the definition we started out with. It's just a different point of view. Eigenvalues and eigenvectors are defined in terms of one another. You can't have a definition that includes one but not the other. Here we start with by defining eigenvectors, and then our definition of eigenvectors includes some real numbers, and we give those real numbers a name. Here we come at it from the other direction. We start with the eigenvalues, the real numbers, and then the definition involves some vectors x, and we give those vectors a name. So it's the same definition approached from two different directions.